This is 2000 AP Physics B exam. 3 identical resistors, each with resistance R and a capacitor 10 to the negative 9 farad, are connected to a 30-volt battery with neglectable internal resistance as shown in the circuit diagram above. Switches S1 and S2 are initially closed, and switch S3 is initially open. A voltmeter, and the voltmeters are always connected parallel to the device you measure the potential difference from. A voltmeter is connected as shown. Determine the reading on the voltmeter. Always before you watch my videos, try to solve the questions on your own, and I'm always going to post the link to where you can find this problem. So before you watch the video, try to solve the problem, then come back and see which mistakes you made and how many points you would get from your solution. So let's look at the information that is given. So there are 3 identical resistors, R, and the capacitor is given, are connected to a 30-volt battery, neglectable resistance. Switches S1 and 2 are closed, and the voltmeter is connected as shown. Determine the reading on the voltmeter. So I have 2 resistors connected in parallel. 2 resistors connected in parallel. So that's going to be 1 over R plus 1 over R, total resistance. And that gives you 2 over R. So it's 1 over, your result flip over. So the total resistance of those 2 is going to be R over 2. So I can replace these 2 with 1 resistor. Let's imagine that this is our resistor. This circuit does not exist yet because there is S3 is disconnected, and the resistance of this resistor that I'm going to place right here is R over 2. Now this resistor R and this resistor R over 2 connected in series, so the total resistance of the circuit is R plus R over 2 gives you 3R over 2. The current in the circuit, I, is equal to the total voltage in the circuit, 30, divided by total resistance, which is 3R over 2. That gives me 60 divided by 3R, and that gives me 20 over R. So the voltage on the first resistor, is equal to I times R. So the current is 20 over R, and resistor is R, so that gives me 20 volts. So the reading on the first resistor is 20 volt. So this would be 20 volts. Switches S1 and S2 are now open, and then switch S3 is closed. Determine the charge Q on the capacitor S3 as has been closed for a very long time. So if the capacitor has been closed for a very long time, then the voltage, the potential voltage on this capacitor will also be 30 volt. So I know the voltage on this capacitor is also 30 volt. The current will not flow if the charge on this side is the same as the charge on this side, and the charge on that side is exactly the same as on this side. So the current stops flowing. So when they say long time open, that means the current is not flowing. The current only goes only from the positive to the negative. And the current only flows when the when the circuit just turned on and the plates on the capacitor are not charged fully yet. So we know the formula of the capacitance is how much charge per voltage applied. So if they ask you for this question, determine the charge. Charge is equal to C times V. The capacitance is 10 to the negative 9 farad, or 1 times 10 to the negative 9, and times the voltage, which is 30. So that gives me 310 to the negative 8 coulombs. For the next part, they say that the after the capacitor is fully charged, the switches S1 and S2 remain open, switch S3 remains closed, the plates are held fixed, and a conducting copper block is inserted midway between the plates as shown below. The plates of the capacitor are separated by a distance of 1 millimeter, and the copper block has a thickness of 0.5 millimeters. And they give you this picture, and then for C part, they ask you, what is, so there's like 4 parts in C. And the first one they ask you is, what is the potential difference between the plates? What is the electric field inside the copper block? On the diagram above, draw arrows to clearly indicate the direction of the electric field between the plates. Determine the magnitude of the electric field in each of the spaces between the plates and the copper block. So because the capacitor is still connected to the battery and the other 2 resistors are disconnected, so let me show you right here. So these 2 resistors are disconnected, and you have the capacitor connected to the battery. So the capacitor still has 30 volt on it. So for the first question, when they ask you what's the potential difference between the plates, the answer is 30 volts. The next question, they ask you what is the electric field inside of the copper block. And so you have many positive charges on this plate and many negative charges on the other side. And copper is a conductor, so the negative charges will move this way, and the positive charges will come over here. And electric field lines are going to go from positive to negative. And electric field lines are going to go from positive to negative. And you also have, still these positives go that way to negative. In this direction. Let me do it like this. So there is electric field lines in that direction still. But because there is positive on the bottom side of the copper and negative on the top side of the copper, there is also electric field going in this direction. And do you see that there is 2 directed fields in 2 different directions inside of the copper? That field cancels, and there is no electric field inside of the copper. So the answer for the second part, electric field inside of the copper, is equal to 0, and electric field is measured newtons per coulomb. So that would be 0 newtons per coulomb. So for the next question, they ask you to draw arrows to clearly indicate the direction of electric field between the plates. And I already have my drawing here, so I'm just gonna make it a little bit neater because you don't want an AP exam it to look the way I just explained to you. So your electric field lines will go in this direction. They will look like this. And like this. And you want the spacing to stay the same, and just to show that they continue passing the copper plate. For the last part, they just ask you to determine the electric field in each of the spaces between the plates and the copper block. So remember the formulas that we went in the past through, that the voltage is equal to the work over per charge to move the charge, and that is equal to the force times the distance over the charge, and that equals to electric field times the distance. So here you have the voltage and you have the distance that is given. So I have the electric field is equal to the voltage divided by the distance. And the distance that separates them is, and I'm counting the space, the air, not the copper plate. So that would be 30 divided by 0.5 millimeters, so that is 0.0005. So that gives me that electric field is equal to 60, and then I have 1,000, because milli, right? It would be the same as 30 divided by 0.5 millimeters. So 30 divided by 0.5 is 60, and milli goes to the top, makes 1,000, correct? So that gives me 60,000, and I can write it was volts over meter, or I could use units as newtons per coulomb. So either one is okay as the measurements in this case. So that would be it for this question. So, and that was 2000 AP Physics B exam question.